Baya. Today I'm going to show how to solve a problem in Thermodynamics, Chapter 2, Properties of Pure Substance. So here our problem. You can see this problem from the book of Yunus A. Single, page 152, problem 3-28. A 1.8 cubic meter rigid tank of contains steam at 220 degrees Celsius. One-third of the volume is in the liquid phase and the rest is in the vapor form. Determine the pressure of the steam, the quality of the saturated mixture, and the density of the mixture. So first, we're going to find the pressure of the steam. We can find this pressure of the steam using the property table. But first, we're going to analyze it. Since the unit is SI unit and the given is in temperature, so one-third of the volume is in the liquid phase and the rest is in the vapor form, so saturated water. So this is our property tables. The table that we're going to use is table A-4, saturated water temperature table, since the given is temperature. So we're going to find 220 degrees Celsius. So 220 degrees Celsius is the pressure is 2319.6 kilopascal. So after that, we're going to find the quality of the saturated mixture. So our mass for saturated liquid and the mass for saturated vapor. But first, I'm going to show how we come up to this value. Like what I said, I'm going to show how we come up to those value of mass of saturated liquid and mass of saturated vapor. So we have this equation, volume is equal to mass times specific volume. So we're going to derive the equation. Mass is equal to volume over specific volume. So this is equation we're going to use to find the mass of specific liquid and specific vapor. First, we're going to solve for mass of saturated liquid. First, we're going to identify the given. The problem stated that we have 1.8 cubic meter, then we also have for saturated liquid now 1/3. Then we're going to find the specific volume. Using the property table, we're going to find the specific volume of saturated liquid, which is 220 temperature, and this is the specific volume. Our specific volume for saturated liquid is 0.001190 meter cube over kilogram. We're going to compute it. This 1/3 came from the volume of liquid phase, so we're going to compute the mass of specific liquid. First, we're going to cancel the unit of cubic meter. So our mass for specific liquid is 504.2 kilogram. Then we're going to look for the mass of saturated vapor. First, we're going to identify, or we're going to find the specific volume for saturated vapor. So this is the saturated liquid and this one is the saturated vapor. So our saturated vapor is 0.08694 meter cube per kilogram. This 2/3 came from the rest of the in vapor form or volume, so we're going to cancel the cubic meter. So our mass of saturated vapor is 13.94 kilogram. Since we already find how we come up to this value, that mass for saturated liquid is equal to 504.2 kilogram and the mass for saturated vapor is 13.94 kilogram, we're going to find the total mass in order to get the quality of determined. So the equation for total mass is Mass total is equal to mass saturated liquid plus mass saturated vapor. So 504.2 kilogram plus 13.94 kilogram is equal to 518.1 kilogram. Then after that, we're going to find the quality. The equation for quality is X is equal to mass saturated vapor over mass total. So 13.94 kilogram over 518.1 kilogram. Our quality X is 0.0269. As you can see, we don't have unit because we cancel kilogram. Then after that, we're going to find for the density of the mixture. So the equation for density is rho is equal to 1 over specific volume. So the volume of specific volume is 0.03474 meter cube over kilogram. I'm going to show how we come up to this value. So this is the equation that I'm going to use, how we come up to the value of specific volume. So we have specific volume is equal to specific volume of saturated liquid plus the quality X times volume of saturated vapor minus volume of saturated liquid. So this is the value of volume of specific volume of saturated liquid and specific volume of saturated vapor. Since we already have a given, we're going to input it. So our specific liquid is 0.001190 and the plus the quality X is 0.0269 times our saturated vapor, which is 0.08609 minus the 0.001190. So our specific volume is 0.03474 meter cube or cubic meter per kilogram. Since I already show how we come up to this value, we're going to compute for the density. So 1 over 0.003474 meter cube or cubic meter over kilogram, our density is 287.8 kilogram per cubic meter. Thank you for listening and have a great day.